day, everyone. My name is Abigail Rose Mibika Bakab. Starting to the introduction to research, our learning objectives for today is to discuss the basic principle of research and planning for research. Second is to explain the various types of research designs. What is research? Research is a systematic inquiry process that includes data gathering, documentation of important information, analysis, and interpretation of that data and information in accordance with appropriate procedures established by a particular academic and professional disciplines. There are three basic principles of research designs. First, principle of replication. To increase the statistical accuracy, the experiment should be repeated more than once. Thus, each treatment is applied in many experimental units instead of one. Second is the principle of randomization. To minimize the effect of extraneous variables, experiments are carried out in different conditions so as to minimize the effect of extraneous variables and cover the effect in the head term as chance. And lastly is the principle of local control. Under it, the extraneous factor, the known source of variability, is made to vary deliberately over as wide range as necessary, and this needs to be done in such a way that the variability it causes can be measured and hence eliminated from the experimental error. In brief, through the principle of local control, researcher can eliminate the variability due to extraneous factors from the experimental error. Now let's proceed to research design. A research design is a methodical, well-organized procedure utilized by a researcher or a scientist to carry out a scientific study. It is a comprehensive coexistence of already identified elements and any other information or data leading to a reasonable and end result. The purpose of research design is to minimize the expenditure, to facilitate the smooth scaling, to collect the relevant data and techniques, to provide blueprints for plans, to provide an overview for other experts, and to provide a direction. There are four types of research design. First, descriptive research. It is a type of research that answers what and how. It is systematically describe a population or a situational phenomenon, a descriptive. Research design can use a wide variety of research methods to investigate one or more variables. It can answer what, where, and how questions but not why questions. Second is explanatory research. A research explains the subject of the research and why, thereby answers what, why, and how. This research sorts the subject matter and answer what and how. Is the exploratory research. This research sorts the subject matter and answers what and how. And lastly, evaluation research. It has a program evaluation, research purpose, systematic assessment, time, money, effort, and resources spent. This sort of research determines the productivity of the subject matter or a program and is therefore quite extensive, also known as program evaluation. It is a common research design that entails carrying out a structural assessment of the value of resources committed to a project or specific goal, and it often adopts social research methods to gather and analyze useful information about organizational process and products. There are two types of evaluation research. First is the qualitative research design. It is a central question that states the objective or the problem, has a preset procedure or sequence in order to answer research questions. It also has the review the generated data, and the collection and analysis of data are done in order to draw conclusions. Second is the quantitative research. A quantitative research analyzes variable relationships in terms of numbers and statistical strategies to review findings and is generally divided into four main types, namely descriptive design, correlational design, quasi-experimental design, and experimental design. This time, if you want to create a research design, first, pinpoint your learning outcomes or objectives. Second is pick out your research questions. Third, develop a research design. Fourth, choose a sampling framework. And fifth, pick suitable methods of data collection. 6. Set up appropriate measurement instruments. 7. Identify proper data analysis techniques and tools. And lastly, contemplate dissemination and publication of your findings. So that ends of my report from the topic Introduction to Research.
Thank you, Miss Abby. So today I am going to continue the discussion. I am Babesy Kansan and we are now going to look at a special class of tests that give us the ability to do statistical analysis in circumstances when parametric tests just won't do. So, they are called the nonparametric statistics, and I'm going to tell you why we need them. From all of our studies of parametric statistics like t-test and ANOVA, we have learned how to compare groups using scale-level data. But what if you only have a nominal data? Well, you have options. So let's imagine that we are having an end-of-semester party and we need to order soft drinks and somebody suggests that we just buy a case of whatever is on sale because people will drink whatever is available. But you think that maybe people prefer one brand over others. So, you offer the class a choice of 6 brands of soft drinks and ask everyone to choose their favorite. But how are you going to analyze this data? How can you tell if people truly have preference for one type of soft drinks or if they are simply choosing one at random? So, most of the statistics that we have used so far estimate population parameters from a distribution of scores in a sample. So, for example, the t-test uses sample variance as an estimator of population variance. Tests like this are called the parametric tests, and they work because the central limit theorem shows us that the distribution of sample means will form an approximately normal distribution. But there is a class of tests that do not rely upon parameter estimations or distribution assumptions, and these are called the nonparametric statistics. So nonparametrics are especially useful with nominal and ordinal level data, although they can also use with interval and ratio level data. So for example, you want to make a comparison whether males or females are more likely to help a person in their either emotional distress or physical peril. Or perhaps you want to know if patterns of soft drinks consumption are the same as the state university as at a private school. So, nonparametric statistics have several advantages over parametric statistics. Number 1. So, nonparametric tests are not susceptible to outliers the way the parametric tests are. So, one outlier score can affect a parameter test by inflating the variance and hence the error term. This can invalidate a conclusion drawn by a parametric test. So you make a type 1 error or perhaps even a type 2 error. So outliers in a correlation can change the direction or the strength of a relationship between variables. But nonparametric tests do not have this limitation because they measure central tendency using ranked data. Ranking uses the median rather than a mean. So for example, If the 10th number in your distribution is an outlier, that outlier can really shift the mean when you add it to other numbers. But when you are considering ranks, it is still just the 10th number no matter how big the actual value is. So the main advantage of nonparametric statistics is that they do not require restrictive assumptions about the distribution. For instance, they do not assume that the soft drink consumption is normally distributed. So non-parametric tests can also be used when you have a non-normal interval or ratio data, such as the data that are highly skewed. Typically, therefore, non-parametric statistics are only used when the data are too skewed to use a parametric test. So another advantage is that the non-parametric statistics are typically easier to calculate by hand, and we will practice doing some of them by hand in order to learn them. However, the main disadvantage of non-parametric statistics is that they are not as powerful as the parametric tests. That means that they are more likely to miss an effect that truly exists or that you make a type 2 error. So, as you get better with statistics, you will be using mostly parametric statistics. But you should keep some tools in your back pocket that you can use at times that the parametric statistics fail. So each parametric test has a corresponding non-parametric test. So here, you can see each parametric test and its corresponding non-parametric alternative. So for example, if you plan to do an independent sample t-test, but the data were highly skewed, you can use a Mann-Whitney U-test instead. If you wanted to do a one-way ANOVA, but instead of groups, you were looking for differences over 5 years of a program, you could do the Kruskal-Wallis test instead. So each of these non-parametric statistics can be conducted in SPSS. But there is another test called the chi-square test that is an ever-present help in times of statistical trouble, and it would be the perfect tool for analyzing our soft drink data. So this adaptability makes the chi-square one of the most popular and versatile non-parametric statistic tests. So that's the end of my discussion. Thank you, and I hope you learned something from me.